Episode 57, Series N-Amp, Dividers Finale, Pitfalls, Spice N-Amp, Sanity Checks, Crash Course Instrumentation, Series Circuits N-Amp, Voltage Dividers. Hook. You now speak series and divider. Today we make it bulletproof with real-world gotchas, quick checks, and a tiny simulation trick so your answers hold up on the bench. One breath recap what we've learned. One path means one current everywhere. Voltage drops add to match the source. Resistances in series add. A divider turns input into a chosen fraction of input. Speak the math as words so it is crystal clear. Pitfall 1. Loading makes numbers sag. When you connect something to the divider output, that thing becomes part of the divider. If your reading suddenly drops, the input you attached is borrowing too much. Use a buffer or choose values that let the divider current be about 10 times the load current. Pitfall 2. Power and heat sneak up on you. Low-value resistors waste power. If parts feel warm for no reason, your values are too small. Say the check out loud. Power equals voltage times current. Make sure each resistor's watt rating beats the math. Pitfall 3. Assuming equal drops when parts are not equal. Two different resistors in series will not split the voltage evenly. Only equal resistors make equal drops. Do a quick ratio check before you guess. Pitfall 4. Tolerance and temperature drift. Real resistors are not perfect. 10% parts can shift your divider enough to miss a threshold. Use a tighter tolerance, 1%, where the exact ratio matters. And remember that temperature moves values a little as things warm up. Pitfall 5. Pot wiper surprises. A scratchy or open wiper can make the output jump or float. Tie the wiper to the low end with a small resistor so failures fall safely towards zero. If the setting changes when you connect the rest of the circuit, you are seeing loading, buffer it. Pitfall 6. Using dividers as power supplies. Dividers are great at numbers, not juice. Do not power active electronics from a divider unless the load is tiny and constant. Use a regulator or a proper reference for rails. 5 sanity checks you can do in seconds. Add-up check. Individual voltage drops should add to the source value. Bounds check. Divider output must be between 0 and the source, never higher. Extreme check. If one resistor is huge compared to the other, the output should sit near the small one's side. If it does not, redo the math. Power sum. Load's powers add to the source power. If they do not, look for a mistake. Talk it out. Say the relationships as words. Voltage equals current times resistance. Output equals input times the share you picked. Hearing it catches missing steps. Spice in 60 seconds mini method. Type a tiny divider into any Spice tool and run a direct current sweep of the source. Read the printed node voltage and the source current. If your hand math and Spice disagree, find out why before you build it. Simulation is a super-fast lie detector. Fun finale nugget. Early radio techs lived by these same ideas. Bias points from dividers, don't load the detector, and quick power checks by touch. Different century, same rules. Final recap. Know the rules, expect the pitfalls, run a quick simulation, and use those 5 sanity checks. Your series and divider answers will be steady, safe, and trustworthy. If this helped, tap like and subscribe, and share your favorite sanity check in the comments. Thank you to Tony Kuphaldt and the open source community for the Model resources that inspire this series.